Okay, so today I can't really do my video on the board, mostly because we're going to be doing a lot of stuff with transformations and stuff like that. And it's hard to do that on the board. So I figured out a way to do it down here. This is my cool table. So this is my transformation notation reference sheet. It's kind of like my little cheat sheet for this chapter, which I love. It's because we're going to be using clockwise and counterclockwise turns in a little bit, and it'll be nice to know what we need to do with them. So we'll come back to this when we start using them, and we'll move it to the side and stuff. So for now, we're going to learn about translations first. I'm not going to go through every single one of these. We'll just go through a few because we need to know what translation notation is and what we need to do once we have the translation notation. So in this one, this is saying we have a triangle at 1, 2, so one of our dots is there, 3 and 1, and then 3 and 4. So here's our original triangle. Okay, so there's our original triangle. Now they're asking us to translate it 2 units to the left and 1 unit up. So translation notation is taking what we're given, which we're given our 2 units to the left, and left is this way. So that means we're minusing. So x minus 2, and if we're going up, y plus 1. So now we just take the points that were given in the first one, and our a prime is going to be 1 minus 2, which is negative 1, and then plus 1 to the y, so 2 plus 1 is 3. So a prime is negative 1, 1, 2, 3. So here's a prime. And then b prime, we're going to do x minus 2, which is 1, and then y plus 1, which is 2. So then this one is 1 right here. So that's going to be the exact same as this a. So b prime is right here. Now, do this guy in x minus 2. So 3 minus 2 is 1. And then 4 plus 1 is 5. So then we do 1 and 5. And we have translated this. So this is c prime. So all we did was shift it. Just slid it over. That's basically what a translation notation is. We're just sliding things over. So let's try it. What are you eating? Oh, they're eating something. So let's not do this one. You can do it if you want, but let's do this. So they're giving us our vertices of P at 0, 0, Q at 5, negative 2, and R at negative 3, 6. And they want us to use our translation notation. So first of all, let's write our translation notation down. Well, they're giving us that we're moving 6 units to the right. So going right is this way, which means we are going positive. So x plus 6, and 5 units up is y plus 5. So now we're just going to use these coordinates that they gave us, and we're going to add the 6 and the 5 to them. So 0 plus 6 is 6. 0 plus 5 is 5. Now, 5 plus 6 is 11. Negative 2 plus 5 is 3. And negative 3 plus 6 is 3. And 5 plus 6 is 11. Okay, so this is how we're going to be writing translation notation. So if we're going to use it in this one we're translating twice. So we have two translations. So first of all, they're giving us our translation notations. Now we just need to figure out what K prime and then K double prime are. You're going to be having to use that. So let's look at our K prime first, L prime, M prime, and N prime. So looking through here, well, our K originally is at -2, and they want us to translate it by x plus 2, y minus 1. So knowing that, I'm going to add 2 to my x coordinate here, which I get 0. And I'm going to minus 1, which I get -3. Now, I'm going to do the same thing as I keep going. So 1 plus 2 is 3. 1 minus 1 is 0. 2 plus 0 is 2. 4 minus 1 is 3. -3 plus 2 is -1. And 5 minus 1 is 4. So now we're going to be taking this prime that we just got, and we're going to translate it again. Don't translate the original one. We're translating the one they want us that we just got. So we're going to take these coordinates and translate it by the second one we're given. So we're going to translate it by this guy right here. So now we're going to do x, so 0 minus 3, which is -3. And then -3 plus 4 is 1. And then 3 minus 3 is 0. 0 plus 4 is 4. 2 minus 3 is -1. 3 plus 4 is 7. -1 minus 3 is -4. And 4 plus 4 is 8. So now we have translated this quadrilateral twice. That's what they wanted us to do. Just translate it twice. Now you see why this is easier to do on paper. So now we're going to learn about some reflections. So this is saying we need to reflect it. So let's do that. So let's graph our original one. So we're going to graph G at 1, 2, 3, 4, 1, 2. And then 1, 2, 3, 4. So this is G, this is H, and this is 1 and 1. This is J. So this is my original triangle. When we are reflecting over the y-axis, let's go back here. I'll show you. So reflecting around the y-axis right here. The y's stay the same. And all you have to do is make the x coordinates negative. I don't know if you can see that because I wrote it in pencil. So the y's will stay the same and the x's will go negative. That's all you need to do. And it's the same thing with the x one, except the x's stay the same and the y's go negative. So this one is asking us to reflect it over the y-axis. So we know right now, right off the bat, that the y's are going to stay the same. So we can just write those down. But now every single x coordinate will go negative. If it's already negative, it will just switch. So it's basically switching signs. So this is now -4. This is now -3. And this is -1. So now we just need to graph this one. So our G prime, we go over to 1, 2, 3, 4, and up 1, 2. And then this is G prime. And then 1, 2, 3, and 1, 2, 3, 4. This is H prime. And this is J prime. And if you've noticed, since we're reflecting, if we were to put a mirror right in between here, it's a reflection. You're just looking at yourself through a mirror. That's pretty much what we're doing. And we reflect it over the y-axis, because this is the y-axis. That's why the y stayed the same and the x has changed. So let's try it with an x one. So this guy right here, we're going to graph the original one. 1, 2, 1. So here's our M. And let's see. 1, 2, 3, and 1. So this is N and this is P. So here's our original guy. He's cool looking. So we know if we're reflecting over the x-axis, oh my lord, x-axis, the x's are going to stay the same. So -3 and -1. Now, all the y coordinates will switch signs. So we have -1, -1, and -4. So now, let's graph it. So we go over to 2 and down. So this is our M prime. And then N prime is right here. You can kind of just like look and be like, well, they're going to be like in the exact same spot, right? We're just reflecting. See? We've reflected it. Isn't that cool? I like reflections because it's like we're just looking in a mirror. I think they're pretty dope. Hey, I'm just making sure I'm filming right because it's hard because my iPad's up there. So let's look at this problem down here. So this says that Roberto is finding the coordinates of the image of a triangle with the vertices 1, 1, 4, 1, and 1, 5 after reflection over the x-axis. We need to describe his mistake and correct it. So if we're looking right here, this is what he's saying. The vertices of triangle A prime, B prime, C prime are -1, -4, or -1, 1, -4, 1, and -1, 5. He wanted to reflect it over the y-axis, or the x-axis, but what axis did he actually reflect it over? Well, right here, he changed all the x ones. So obviously, he actually reflected it over... Okay, I can't spell, guys. Reflected over y. But now they want us to reflect over x, so we need to correct it. So correcting this is easy. A prime, B prime, and C prime. Well, if we're reflecting it over the x-axis, we know x's stay the same. That was his mistake. He just changed the x's when he should have changed the y's. And then that's all you have to do. So let's try this guy. Because this guy says this triangle JKL has these vertices. So without graphing, we need to find coordinates of the vertices of the triangle after 2 reflections. So first of all, we need to reflect over the x-axis and then reflect over the y-axis. So we're going to do J prime, K prime, and L prime. Then we're going to do J double prime, K double prime, and L double prime. So our first one, we need to go over the x-axis. When we go over the x-axis, the x's stay the same. So I'm going to take my x's and leave them the same. So I have -7, 7, and 2. Now I'm going to take my y's and just switch their signs. So 4, -4, sorry, -4, -1, and +2, because that's a -2 and I have to switch the sign. So it's +2. But now they want us to reflect this guy that we just got over the y-axis. So when we're reflecting over the y-axis, the y's stay the same. So -4, -1, and 2, but the x's switch. So this is 7, -7, and -2. We have just reflected this twice. And if we were to graph it, it would look pretty cool, honestly. But that's just me. Cool, right? I enjoy this kind of stuff. I enjoy it. I don't know why, but I do. Okay. So looking at these are all like reflections and stuff. So, you know, but just look at this. If we can look and see, you're just like, which axis is the point reflected across? Just look right at this. Which one? Well, it looks like our x's are the same. So obviously this is the x one. X-axis. Right here, the y's are the same, so it's the y-axis. Cool. Reflections and translation notation are the easier part of this section. Because right here, let's just write our translation notation. I'm not going to have you guys graph it. You can graph it if you want. That's fine. But translation notation is all you really need to know. So you just need to know your x and your y. So if we're translating 4 units to the left, that is our x. Left and right is x. And left means we're subtracting. And up and down is y, and we're going up 3. This is what they want. They want you to know what translation notation is. Translation notation is what you are taking each of these points and moving them. That's all you need to know about translation notation. Okay? So let's move on to rotations. A lot of people don't like the rotations, but once you understand the concept of them, they're actually relatively easy. So looking at this, they're giving us the exact same triangle. And I'm going to do all of these because they are going to they're going to blow your mind, honestly. It's going to be amazing to watch what I'm about to do. I need to check my... Oh, I'm dropping stuff in my house. Okay, so let's look at this. We need to go 90 degrees clockwise about the origin. Well, let's get my sheet out. So my sheet, this is my clockwise, and this is my counterclockwise. So when we're looking at clockwise turns, whatever coordinate, so if we're given, like this guy right here, so we're given this 3, -1. Well, basically, it's going clockwise is saying whatever y coordinate you have will move out front. It becomes your new x coordinate, and the x coordinate will go in the back and change signs. That is a counterclockwise turn 90 degrees about the origin. So if I'm doing that, right here, that means my y coordinate comes out here and my x goes behind and goes a different sign. So this means this one, my y coordinate comes out front and my x goes behind and becomes negative. Again, y coordinate comes out front and x goes behind and becomes negative. We have just rotated this 90 degrees clockwise about the origin. Now let's graph it. So we go to -1 and then -3 and then -4 and -5 and then -5 and -1. It is now rotated 90 degrees about the origin. Okay, so what if we go counterclockwise? Well, counterclockwise, we're moving the y up front still, but now when we move the y up front, it becomes negative. But when the x goes back, it stays the same. It doesn't change its sign. It'll just stay whatever sign it is. So this time, let's do that. So this time, we move the y up front, and whatever sign it is, if it's negative, it's going to go positive. So let's move this sign, or move this number out front, because the y's are coming up front. And since it's negative, it actually becomes positive. And then the x goes in the back and doesn't change. Same thing here. It'd be 4 and 5. And then here it would be 5 and 1. Because when we move the x's back, they don't change. When we move the y's forward, going counterclockwise, they do change. And these would all change because they're all negatives. So they would all change to positives. So now let's graph it. And we go 1, 1, 2, 3. And then we go over to 4. And up to 5. And we go over to 5 and up to 1. And we have just rotated this 90 degrees counterclockwise about the origin. Okay, let's do 180 degrees clockwise about the origin. And if you will notice on my paper here, clockwise and counterclockwise rotation 180 degrees are the exact same. So we can actually do problems 3 and 4 at the exact same time. What happens is the numbers in the coordinates you're given, so the x's and y's will stay in the same spot, but they will change signs. So if we're given the 3, -1, it actually is now -3, 1. And this would be -5, 4. And that's -1, 5. And since I told you that they're the exact same for counterclockwise and clockwise, this one is the exact same. And now let's graph it. So go over to -3 and up to 1, and then -5 and up to 4, and then -1 and up to 5. And same thing over here. And they are the exact same triangle. So here's another quick secret. Not really a quick secret. Here's a fun secret. Now they're wanting us to do 270 clockwise and counterclockwise. Well, guess what? Counterclockwise and clockwise about the origin, 270 degrees, the exact same thing. And if you will notice, clockwise, 270 degrees clockwise and 270 degrees counterclockwise are the exact same thing as 90 degrees counterclockwise. So look at this. These 3 are the exact same. So what we can do is, knowing that, it's this right here. We already have done this, and now we're just going to do it 2 more times. Because these are the exact same, which I find fascinating. So I'm not going to graph them, but they're the exact same as this guy, right? I think that's pretty cool. I don't know why, but I think it is. So let's look at something like this. It's not given for us, so we're going to have to graph it first. So we're given at -7. So I got to go over 7. 5, 6, 7, and then up to 8. 5, 6, 7, 8. So here's my first dot, which is R. And then -7 and up to 2. And -2, 2, and up to 2. So here's my triangle that they're giving us first. It's my RST. So I need to find R prime, S prime, and T prime. And we're going 180 degrees about the origin. Well, what did we learn when we're going clockwise about the origin? 180 degrees. Well, we go back to our little cheat sheet, which I recommend. Like, this is the most amazing cheat sheet ever. So if we go that way, 180 degrees clockwise about the origin, everything stays in the same spot, but the signs change. So we know that. So the signs change. So this is now 7, -8, 7, -2, 2, -2. And now let's graph it. Who's that? Sorry. Oh, someone has a surprise for me. Sorry, I'm in the middle of doing this. Okay, So let's go over to 7. 1, 2, that's 5, 6, 7, and down to -8. 5, 6, 7, 8. Back to 7 and down to 1, 2, and over to 2, and 2. And look at this. We've rotated it 180 degrees. Isn't that cool? Look, whoop. I like that. Not cool? Cool, cool. Right? So, I'm kind of understanding the basics of rotations. I find them fascinating. So, let's see. Hang on. I'm going to move some things around. So, looking at these pictures here, we need to identify each transformation, if it's translation, reflection, or rotation. So, looking at this guy, well, this is obviously what? Well, that's a reflection, because he's reflecting himself. This guy, they're moving. Whoop. I like how I did that. Whoop. They're moving this way. So they are translating. And this is they just knocked some stuff over upstairs. This is the Eye of London, and it's a big Ferris wheel, and it is a rotation. Cool, huh? People are texting me. Oh. Hang on. People are emailing me too. Oh, nice. Oh, I love people. Yeah, I'm getting there. Sorry. People are being so sweet. I love them. Okay, so let's do this. Sorry, guys. A little emotional right now. Okay, we can do this. So if we're going 90 degrees clockwise, which means our Y's are moving out front and the X's are changing on this guy. And we're given these coordinates. So this becomes Y is 4, -1, 1, -3, and 3, -5. See? Easy peasy, right? Now, we know that 180 degrees is both the same for clockwise and counterclockwise. And it's just they stay in the same spot, but switch signs. So -1, -4, -3, -1, and -5, -3. Oh my. And then counterclockwise, the Y's are still moving forward like they did up here, but they switch signs. And the X's don't switch signs this time. So that's pretty much the difference. So the difference between counterclockwise 90 degrees and clockwise 90 degrees is the Y's are still going to move forward, but when you're moving clockwise, the X's change signs. When you're moving counterclockwise, the Y's change signs. That's pretty much this difference here. So now it's -4 and 1, -1 and 3, and -3 and 5. See? Once you understand and memorize which rotation you need, it actually is super easy. We know that 180 is both the same for counterclockwise and clockwise. Counterclockwise 90 degrees is also the exact same as 270 degrees clockwise and counterclockwise. So really the only odd one out is the clockwise 90 degrees. So let's move on to some dilations. So our dilations mean we are actually changing the way things look on here. We're making them bigger or making them smaller. So, this spells cat. I like that. It spells cat. So let's graph our first one. So here, we actually have our origin is down here. They made it a little different for us on these ones. So our origin is actually right here. So we're going to graph our first guy, which is at 1 and then 4. So there's our C. And then 2 and 2. Here's our A, and 5 and 5. And here's our T. So here's our first cat. It's so cute. And now we need to just dilate it by 2. And when we're dilating, we're just multiplying each of those numbers. That's it. That's what a dilation is. We're making it bigger. So let's dilate this guy. It's like, you know, you go to the eye doctor and they stick like those drops in your eyes and you get your eyes dilated. The exact same thing we're doing to math, except I don't have a dropper to actually do it. It's just gonna, whoop, it's just gonna do it magically. I'm gonna multiply things and it's gonna do it magically. So we're gonna do 1 times 2 because this is our dilation factor. So 1 times 2 is 2. 4 times 2 is 8. 2 times 2 is 4. 2 times 2 is 4. 2 times 5 is 10, and the other one is 10. So now, let's graph these and see how big it got. Why is my voice doing that? I don't even know. 2 and 8. 4 and 4. So this is C prime, A prime, and T prime. Look how big our cat got. He's a big triangle. He just got so much bigger. Sorry, I'm in a good mood. People just donated to my GoFundMe raiser, and I'm in a very good mood about that. That's helpful to me. And I'm kind of crying about it because, wow. Okay. It's fine. We got this. All right. Let's graph this rectangle. And we'll dilate it. People freak out. Okay. My kids freaked out when they saw this. They're like, oh my gosh, it's a fraction. I'm going to show you a trick. A little secret. It's a fun secret. Are you ready for this? So first of all, let's graph this first dude. So go over 1, 2, and up to, go over 1, 2, and up to 8, which is right here. I'm eyeballing it, but I should know. 6 and 8, and 6 and 2. So here's our little rectangle. He's so cool, isn't he? So we have R, S, T, and U. He's a cute little triangle. Or not triangle, rectangle. Hello, brain. I need my caffeine. That's how my day is. All right, got the caffeine in. Okay. Well, now we have to dilate it by the factor of 3/2. Okay, this is where people freak out. Don't freak out. It is a fraction. It's not the end of the world. I promise it's not the end of the world. Okay? I can guarantee you, not the end of the world. So I'm just going to multiply. So how many 2's do I have? I have 1, 2, 3, 4. So I know that I have 4 of those. So I'm just going to multiply once. So I'm going to do 3/2 times 2. You do realize that you can put any number you want over 1, right? Oh my gosh, guys, it just got so much easier. What just happened with this math? We can cross multiply. What's 3 times 1? Oh my gosh, 3 times 1 is 3. What? So now everywhere you see a 2, it becomes a 3. Right? How cool was that? Okay, so now let's do the 8s. We have 2 of them. So 3/2 times 8 over 1. Uh-oh, don't panic, guys. Don't panic. I'm panicking. Wait, I shouldn't though, right? That cuts it down to a 4. Well, what's 3 times 4? Hang on. 3 times 4 is 12. What? So everywhere that there's an 8 is now a 12. Oh my gosh, cross multiplication saved my life. So now let's do the 6s. I think I just got really into this. Well, put it over 1. Oh no, I don't want to do a fraction. Oh, well, I can cut that down to a 3. Wait, what's 3 times 3? Oh my gosh, 3 times 3 is 9? Guys, I just figured all of my points out. Can you believe that? Now let's just graph it. So go over to 3 and up to 1, 2, 3. So here's my R prime. It's a cute little R prime. Then we go up to 3 again and up to 12. So that's my S prime. Go over to 9 and go up to 12. Just right up here. And that's my T prime. And go over to U, which is 9, and up to 3, which is U prime. And then fill in my little lines. Look at this. That was so easy, right? Honestly, people just whoop. I don't get it. You guys freak out for no reason, and it makes me laugh. You shouldn't freak out. That's just me, though. Just saying. Cool, right? Dilations. Dilations are really, simple. Okay, so let's do this guy. So find the coordinates of the vertices of each figure after a dilation with the given scale factor. So we have to graph the original and then a dilation. So right here, our dilation factor is 3. So let's graph the original one at -3, 2, 3, and 4, which is V. -2 and 0, which we don't have to move, woohoo, which is X. It's a weird X. And then 1 and 1, 2, which is a W. So here's our first little triangle. So now, multiply each number by 3. Easy peasy, right? 3 times 3 is -9. And then 12. And then -6. And 0, obviously, because anything multiplied by 0, 0. And then 3 and 6. So now, graph this little dude here. So we're going to go over to -9 and up to 12, which is our V prime. And then we're going to go over to -6 and 0, because don't go anywhere. And then go over 1, 2, 3, and up to 6, which is our W prime. And this guy got huge. He's on steroids, guys. My goodness. Look at that. Dilations. Very easy, honestly. I like dilations. They are pretty simple once you understand the basics of them. Okay. So now, let's move on to they want us to do some composites or compositions of some transformations. So, right here, they're giving us 1 point. So they give us this point. A is 3 and -5. So here's our A. They want us to do a translation first and then a reflection. So we need to graph each of these points as we go. So we're going to have an A prime and an A double prime. So our A prime, the X is staying the same, obviously, because look, the translation, we're not moving the X. So our A prime, the X is 3, but we're going negative how many more? Y is going -4. So it's 9. So A prime stays at 3, but goes down to -9. Here's our A prime. But now they want us to reflect it across the Y-axis. So our A double prime When we reflect across the y-axis, what stays the same? Well, the y's stay the same, and the x's change. So now we go over to -9, because I know we're down here, and then 1, 2, 3. And there's our a double prime. Right? So now let's do this guy. Let's do this x one. So we have a 3, because these are all the same, which is nice. 3, -5, so there's our a. So what's our a prime? Well, a prime is we are adding 4 to this. So it's 7. And then we are adding 1 to that. -4. Hi, Loki. 7 and then -4 right here. So there's our a prime. Now we need our a double prime. And we're reflecting about the x-axis, which means the x's stay the same and the y's change. So now we go over to 7 and up 1, 2, 3, 4. And there's our a double prime. So we're just we're compiling. I don't know, we're doing something, we're combining. There we go. We're combining what we just learned in those few worksheets into multiple things. So they have to do multiple steps with them. Like this guy right here. So let's do this guy. So we have a 4 and a 2, which is our P. And then a 7, 0, which is Q. And then a 9 and a 3, which is R. So here's our original guy. Okay. Now we have to translate it. So P prime, Q prime, and R prime. So they want us to translate it first. So x's will be -2. So we get 2, and then y's go up 3. 5, and then 5, 3, and 7, 6. So let's graph our prime one. So we go over to 2, up to 5. So here's our P prime. Over to 5, up to 1, 2, 3. There's our Q prime, and then 7, and up to 6. Right there. And there's our R prime. Okay, so this guy now is graphed, not connecting. So now our P double prime, and our Q double prime, and our R double prime. This says they want it 90 degrees clockwise about the origin. Well, what did we learn? Well, we learned 90 degrees clockwise, the y coordinates move up, the x coordinates move behind, and switch signs. So the y coordinates of this guy move up, and the x's move behind and change signs. Okay, now let's graph this dude. So go to 5, and then -2. Here's our R double prime. Go over to 3, down to -5, which is our Q double prime. Then go over to 6, and down to 7, which is our, no, this was P double prime. Hi guys. P double prime. This is R double prime. Hey, look at this. And we have first we have translated it, and then we rotated it. See? We're just like, we're compiling things and having fun with that, right? I find this fascinating. I like it. I like it a lot. Okay, so now let's move on to congruency and similarity. Yeah, congruency and similarity. Hang on, I make sure these are, I moved them out of my, guys almost fell off my chair. That would have been hilarious. Whee! I'm coming back. Now I went too far. Too far. Too far, man. Okay. All right. Determine. Oh, my Lord. That is some good stuff. Let's see. Now, let's determine whether each polygon is congruent. Right? I think they both are. I don't remember what I wrote down. Hang on. I'm going to check my cheat sheet. My homework. Oh my. There's so much here, guys. I'd be surprised how often I've done these homeworks. Oh, they are. Both of these are. So looking at these, this is just flipped, but because they have these congruency statement lines in the exact same places, these are all congruent. And the same thing here, but the same thing with this one is it shrank, but the shrinkage, the dilation, is a dilation of a factor of a half, because you're just cutting these in half, and it's the exact same thing. So it's still congruent. Okay, so writing congruency statements. This is where a lot of kids, you have to do a lot of writing, and it frustrates people. So this says write congruency statements for each set of congruent figures. Identify all the pairs of congruent parts. So this is a lot of writing. So we're going to look at this one. I don't want to look at this guy. So let's look at this guy. This guy's been reflected. If you put a mirror here, he's been reflected. So we have to take that into account. So I'm going to start here. I'm going to say, well, line NO, and congruency statements are an equal sign with a little like dude like that. So line NO is congruent to line SV. Put it as SV. If you put it as VS, it's the wrong way. You have to make sure you are putting them the right way. So if I do NO, it has to be SV. If I do ON, it could be VS. So I did NO, so it has to be line SV. So now, what if line MN, let's find out what that one's congruent to. So line MN is congruent to line TS. Line MO is congruent to line TV. Why are you gross, Loki? You're the loudest lick. Okay, so now that we did that, now we need to find congruent angles. And our little angle sign is like this. So I'm going to do angle N is congruent. What angle is angle N congruent to? Well, angle S. Angle M is congruent to angle V. Nope, angle T. Sorry. I was looking at it wrong. Ha! I'm smart. See? I make my own friggin' mistakes, and then I'm like, I'm dumb. So angle O is congruent to angle V. See, sometimes even I make mistakes. Caffeine time. Dumb. Okay, let's look at this guy right here. If the umbrella shown, JLK is congruent to NLM, so JLK is congruent to NLM. If this angle, the angle of JKL is 66, then what's the angle of NML? Well, if they are congruent, it's also going to be 66 degrees. Now they want us to say, well, the line MN right here, this dude, is 15 inches. Well, what is J? Oops, sorry, not that one. This line. Hi, guys. Again, messed up. 15 inches. Well, what is KJ? Well, KJ is also 15 inches. That's congruency, right? And just, ta-da. Now you get my fun times. Okay, so now that we know what congruency kind of is, we need to draw arc and tick marks to identify corresponding parts. And then we need to find the value of x. So let's look at this guy up here. So arcs and tick marks are basically stating which parts are congruent. So I know that A is actually congruent to E. So that's an arc. Arc goes on angles. Tick marks goes on lines. I know that C is congruent to D. And B is congruent to B. Okay? And you have to differentiate. So when you get this angle, it gets 1. This one gets 2. This one gets 3, depending on how many angles there are. So now I know that this, that's a tick mark, is congruent to this guy. This guy is congruent to this guy. And this guy is congruent to, there's 3 lines there, this guy. Those are my tick marks and angles. You have to do that. But now let's find x. So we're given this 4x minus 2 and this 22. Well, if they're congruent, it means they have to be equal. So we get 4, oh my gosh, that's a 3, guys. 4x minus 2 equals 22. Well, let's figure this out. I'm going to add my 2. My students would kill me right now. You know why? I'm using a pen. And I'm not supposed to use pens in math. I get mad at them for using pens in math. And here I am using a pen. Don't play in that stuff. Okay. Well, what's 24 divided by 4? Well, 6. What? X is 6. So this guy wants us to find, ooh, something's going on. Hang on. I'm going to show you a secret. Well, not really a secret. I'm going to show you something. You know how we learned yesterday about, what did I do over there on my homework? Hang on. I'm looking at something. I don't know what I did. Oh, I know what I did. Never mind. Okay. You know how we learned yesterday about the Pythagorean theorem? Watch this, because I don't know what to do here. You know, there's nothing. I mean, these are all congruent, but watch what I can do to get, I need to figure out what x is. Pythagorean theorem comes into play. So I'm going to do 5 squared plus 12 squared equals c squared, because I don't know what this dude is. So 5 squared is 25. Oh my gosh, guys. I should not use a pen. My students are going to be so mad at me. And this added together is, yeah, I'm smart. What am I doing? Yeah. Why did I write that down wrong? Yeah, anyway. So that is 169 equals c squared. Now I take the square root. I know that c equals 13. So right here equals 13. Well, oh, I see what I did. I get it. I'm smart. Hey guys, good morning. So now we know that this and this are equal to each other, and I have to solve for x. X plus 3 equals 13. What are you getting into? Minus 3, minus 3. So our x equals 10. See? Can you not, please? Thank you, sir. Oh my goodness. Those are congruency stuff. I like congruence. I do. I do. Sometimes. Well, sometimes I don't. Really depends on the day. So, on this figure, I want us to draw arc and tick marks to identify corresponding parts again. Well, easy peasy lemon squeezy. So, this is congruent to that. This, and this, and this, and this. So I know this, 1, 2, and then 3 right here. Your drawings come out like all jacked up, but you know. So now they want us to find the value of x. Well, if this is congruent to this, all we have to do is 4x minus 9 equals 15. And then add 9. 4x equals 24. Divide by 4. x equals 6. Ta-da! I know, how cool is this? I don't feel like you guys actually care as much as I do, but this will help, I promise. It does. I promise it does help. I like it. Of course, I think you guys think I'm crazy. I think I'm crazy, slightly. Ha! It's fine. Similarity. So the following figures are similar, right? Similarity statements. So the difference between similarity statements and congruency statements, there's not really much. So a similarity statement, you still have to write the congruency statements afterwards. But a similarity statement just states if they're similar. So, yes. So similarity. So I have A, B, C, and F, E, D. Because they're flipped, right? So I have to make sure that what I'm writing is in the exact same order. Like no matter what. It has to be in the same order. Because if it's not, then we have a serious problem. So, triangle A, B, C is similar, that's my similar sign, to F, E, D. See? Isn't that cool? That's it. That's a similarity statement. And then go through and write your congruency statements, or your congruency thingies. So your side AB is congruent. It's supposed to be a straight line. Congruent to FE. Side BC is congruent to side ED. Side CA is congruent to side DF. And then angle A is congruent to angle F. Angle B is congruent to angle E. And angle D is congruent to angle C. So this is a similarity statement, and these are your congruency statements. You just have to know how to write them. So right here, A, B, C, D, W, X, Y, Z. Well, A, B, C, D is similar to W, X, Y, Z. That's it. And then just write congruency statements. So now, let's determine whether each pair of polygons is similar. Well, I can already see right here that they're not. And the reason I can see that is I know that 4 divided by 8 is 2. But right here, 7 divided by 3 is not. So right here, they are not similar. Because they have to be proportional. This one is, because it's proportional. I don't know how to spell proportional. Yeah, it's proportional. Yes, it's proportional. My brain does not know how to spell that word. Ha! So let's find the missing side length then. How did I find the missing side length of that? Ah, write it in a proportion. Ha-ha. I'm smart. So we're going to write these in proportions. And I like proportions. So what we're going to do is I wrote it as an x over 12 equals a 3 over 8 because the sides match. Because I have an x and a 12 and a 3 and an 8. And then I just do cross multiplication, which gets me to 8x equals 36. And then divide by 8. And x equals 4.5. So we're just going to be using proportions. My voice is going. Guys, hello. Why? I don't know. So let's use a proportion on this guy. So I'm going to use x and 10. X over 10 equals, and I think on my paper I did it as 21 over 10.5. Just make sure if you're writing a proportion, whatever you use on the top, you have to keep using on the top. So if I used my x on the top, for the first one, whatever one I have to use it from the other triangles. So like that. Then I multiply. So I get 210 equals 10.5x. And then I divide. So x equals 20. So similarity, we use proportions a lot. And I love proportions. They're kind of fun. So, like right here, find the missing side length. So I'm going to do x over, that's an 8. Oh my gosh, guys, pens. Ooh, I'm frustrating myself. X over 8 equals 4 over 5. I'm frustrating myself with this whole pen thing right now. Like, I should not be using a pen, but I am. Which equals 5x equals 32. And then divide by 5. Right? Yeah. And x equals 6.4. So it's just all a matter of learning how to set up proportions and making sure you're setting them up right. So let's set up this guy. And how did I set that one up? So I did 15 over 20, but let's set it up a different way. So I want to set it up slightly different so you guys can see, you can choose your ways. Because lately I've just been doing it where I have the x over this one and then this over this. But what if I set it up where I'm using the same side? So I'm using the same shape to set it up. It's going to be the exact same thing. So if I do 15 over x instead, so I'm using this. So 15 over x equals 20 over 12. Okay? Ooh. Right. And it's going to be the exact same answer. It'll come out the same way. Because we do 20x. And then 15 times 12, which is 180. And then divide by 20, which is an x equals 9. So you could have set it up this way by doing this and this, but I set it up the other way. So on my paper, I actually set it up with the 15 over 20 and the x over 12. And I still got x equals 9. It's the exact same thing. You can set it up either way as long as you're making it so you're setting up the same way with the exact same things. So it's like I couldn't have set it up where I did the 15 over x and then I chose to do 20 over 8. That would have messed me up. You have to make sure you're doing the exact same thing for the exact same one. It's just the way the math has to be. Right. Yes. Okay. So that's similarity, congruency, and transformations and stuff. So I don't know how to get this to you guys. So this is the most amazing thing ever. I actually have a couple of these cheat sheets that would be so amazing if I could get them to you guys. So tomorrow, I know this was a long lesson, I just realized it, but it's kind of important to know, you know? So tomorrow's lesson, let me see what we're learning tomorrow. Tomorrow's lesson might be a little long. I hope not, because it's not too much. It's only what? Honestly, it's only like 3 worksheets, but it's dealing with volume and composite volumes. Sometimes this might take a little longer. So I'll try to work on, do this on here again because it's hard to do it on the board. So hopefully you got a lot out of this one. I liked doing this one. Any questions, comments, let me know, and we'll go from there. Thanks, guys.